to shorten it. Maurice Dawson is an assistant professor of IT and management within the College of Computing at Illinois Institute of Technology. I hope I pronounced it well. Additionally, he serves as a director and distinguished member of Center for Cybersecurity and Forensics Education, again still at IIT. Before joining academia, he was an engineering manager for drones, sounds familiar, and senior program manager for rotary wing aircraft. Rotary wing, like helicopters. Dawson completed a postdoctoral study in information science at the University of Fernando Pessoa. Wonder whether it's South America. He has a doctor of computer science. He has got two doctorates from this intro. One is a doctor of computer science from Colorado Technical University. Another PhD in cybersecurity from the Intelligent Systems Research Center at London Metropolitan University. Dawson has recently received his fourth Fulbright Scholar grant to teach and conduct research at BIUST. That is now. He just started today, a few minutes ago. Additionally, he is the co-editor of developing next generation countermeasures for homeland security threat prevention and new threats and countermeasures in digital crime and cyber terrorism, published by IGI Global in 2017 and 2015, respectively. The US States Department of Defense even recognized him for the roles he played in information assurance management, level 2 and level 3. Again, for cybersecurity service provider manager and information insurance systems architect and engineer. That is level 1 and level 2. Now, this is where interesting. His research areas are cyber operations, software assurance, cyber strategy, and cyber terrorism. These are the guys that the former President Donald Trump wouldn't listen to when he talks about Russian threats. He's in the Midwest Association of Information Systems president, senior fellow at the American Public Leadership Foundation, and he's also a senior member of IEEE. I think that's his introduction. I hope we'll enjoy his presentation today.
All right. Well,
back to you, Dr. Maupu.
Yeah. So thank you for the warm introduction. It is a pleasure to be here at BIUST and Palapi. It's a pleasure. So what I'm going to present, it's called the Framework for the Development of Virtual Labs for Industrial Internet of Things and Hyperconnected Systems. So this presentation was presented in Tunisia. Myself and my co-authors, Francisco Garcia Martinez, and then Pedro Tavares out of Pucallpa out of Dominican Republic. And so Francisco was a graduate student from, I believe it was the Technical University of Madrid. And what we did was we looked at how to create an expensive environment to do IoT. So you think about recent cyber attacks, and I hear echo, so if someone could turn off their mic, that'd be great. So if you think about recent cyber attacks and how a lot of them have been on industrial systems, they've been on power grids, this is to create a lab to focus on just that and to teach people at a affordable price. So a lot of the research I do is in developing countries or countries that do not have very expansive environments for doing teaching various concepts. So just a quick thing. So my background is also in developing cybersecurity curriculum and accrediting it to our national security agency. And so what you see here is just two letters from a previous university. This is from University of Missouri, St. Louis, where I was the National Center Agency point of contact. So I was the point person in terms of navigating the accreditation with the NSA. So that's what these letters are. So these letters are just saying that, hey, you've done the course alignment, what they call the knowledge units into the curriculum. I've done other things in terms of making sure that the faculty are doing research, labs, grants, all these things that are needed to become a premier university in terms of cybersecurity. So I've done it 2 times, and I've actually just done it a 3rd time with Illinois Institute of Technology. And we're hoping that we'll get the accreditation. That was just submitted right before I came into your country. And so it's just showing that, this is what I've done. And so the actual papers that go along with this presentation pretty much outline how that stuff was done and how the course curriculum was mapped directly in terms of labs and stuff like that. And what I'll do is after the presentation, I will send out the paper to this particular talk that was published at IEEE. And then the other one that was published with Presidia Computer Science for software assurance specifically. These are just some items and kind of outlining kind of the importance of this talk. So there were a number of papers and edited books that were published regarding this topic. So the first one is New Threats and Countermeasures in Digital Crime and Cyber Terrorism. This is interesting because this outlines kind of the need why these lab environments are needed. So like in Ethiopia, there was equipment, there was software that was created by a company, FenceBuy, German company. And so what this did, you get these little messages, these flash messages that say, hey, hit your opponent that you don't like, that you're voting for. So an individual would actually hit their opponent. And then from that moment on, cookies would be input in their browser and it would start tracking that person. So imagine you think you're playing an innocent game, because I'm pretty sure a lot of people may be using social media like Facebook and stuff like that. So you're playing an innocent game and then you say, hey, this is what my thoughts are. From that moment on, you're being tracked. And so that was occurring. In other countries, they've done similar things where they've tracked maybe political dissidents or people that do not agree with the thought of what is going on in the country and stuff like that. And then also with the cyber terrorism, you think about Stuxnet and Flame, what happened with the Iranian centrifuges, that is an entirely, I guess, a new scenario in terms of warfare. So you think about how complex it was. Individuals found out that it was a Siemens hardware. It was a PLC, programmable logic controller, a PLC that was used in the within the organization, and they were able to program it in a way that the actual end user would look at the screen and they would see that everything was okay, but in the back end it was running faster and causing it to burn up. That it shows you the complexity in the attacks on critical infrastructure. So there is a presidential directive in the States that covers critical infrastructure, and manufacturing is a critical piece of infrastructure. When you think about countries, especially here on the continent where agriculture is really important, there's countries like Senegal where agriculture makes a significant part of the gross domestic product. Attacking agriculture or in manufacturing facilities is detrimental to a country's GDP, and it could cripple them. So when you think about that, that is one thing, but then also think about what we call hyper-connected systems. So these are systems that are connected to one another. I'll give a prime example. Coming into here to the university, I got access to the guest network. There's also other networks here, right? There's guests, there's a faculty, I think there's a student network. But on the guest network, it didn't ask me for any credentials. It just said, all right, are you in the guest network? Will you do anything wrong? Okay, I click accept. But the other interesting part is my mobile device, your mobile device is your Bluetooth network. That's a personal area network. That's your, 30-foot personal area network. The problem is when you bring any device onto a network, you are bringing on all the issues of that extra device. For example, my mobile device can have tons of malware, right? I can launch attacks from my phone. I can have a program called Kali Linux, and I can have Kali Linux loaded on my phone, and I can use that to launch attacks. I can do privilege escalation, a number of things. And then if I have a mobile device, and for those that have jailbroke phones, if you have sideline an app, right? You sideload an application. So maybe you have a Huawei device, a newer Huawei device, and it's no longer added on the Google Store. You're like, okay, well, I still want to have Facebook. So what you do, you sideload an app, which means that you bypass a number of security mechanisms in your device, and you sideload the app. A lot of those apps that you sideload, because those software that you use, will actually cause and create backdoors in your system that other apps can take advantage of. So now this mobile device has been sideloaded and there's malicious software in here, but yet I'm able to take this on the guest network. And then from there, there's no telling what could actually happen to that network. So that's the whole thing with hyperconnected systems. There's a paper here. It's called Cybersecurity Industry 4.0, the pitfalls of having hyperconnected systems. This particular paper is interesting because this paper came from a conference that I was invited to be a keynote speaker for in Japan, right? It was the International Society of Strategic Management or something like that. So I was invited to actually be a keynote speaker because in terms of Industry 4.0, the United States and Germany are leading that particular, leading that, I guess you can say that, that era or that technological thought. So the United States and Germany is leading, and Japan, they want to make sure that they are going to be, part of that new wave. So Industrial 4.0, it sounds fancy, but all it is bringing more internet connected devices into the manufacturing, or to bringing it in the manufacturing floor. So you think about RFID, robotics, artificial intelligence, adding these items into the manufacturing floor. For example, like in my country, manufacturing is a part of our GDP, but the jobs, a lot of it's being automated, right? So robotics, you have everything, the line itself, a lot of that is just robotics, right? So imagine being able to bring in malicious software that affects the actual, I guess you can say what is programmed, the algorithms that these machines are operating on, how they're operating, how they're looking for defects and stuff like that. Being able to affect stuff like that creates serious issues because everything's automated, but really the people that are doing the check aren't actually maybe the people, just be maybe another group of machines. But now you've actually altered what they should be checking for and stuff like that. So that's what this right here talks about. Also, when you think about, we'll think about energy plants, right? What actual checks are in place for systems actually on the network and the actual computing systems that are running daily tasks? You think about HVAC, right? So you think about, heating and cooling. You think about water boilers. A lot of those systems, they have embedded operating systems. And a lot of them are older. They may have like Windows 95 or something like that. Something that is old and it doesn't get outdated. That's outdated. When you have an embedded system, you may have to personally go and update it yourself. If not, it's just a system that stands there on the network. So now that becomes your weakest point. Imagine you're playing football, right? So you're playing football and you're thinking about where to take the ball at, right? You're like, okay, I see the goal, but you're looking at the team and everybody's a star player. And you're like, okay, well, I know this guy over here. He's not a good runner and he's not a good blocker. You go to the weakest point. So you're going to go to this guy. And that's the same thing when you think about attacks. You're going to the weakest point. And so that's what this particular paper is talking about. And also is talking about there needs to be a system in place that accredits and certifies actual technology or technological devices that are going to be brought into this manufacturing floor. It is really important. Going to the next paper, Issues in Cybersecurity, Security Challenges in the Dominican Republic. This one was interesting because there are numerous countries now getting on board with cybersecurity. So what is happening is you're having attacks, right? So a lot of attacks have been going towards government, right? Everybody's they've been trying to attack the federal government. For years, I actually started cybersecurity back in 2000, working in the United States Army and 3 Corps down at Fort Hood. And so we had computer network defense, we had all this neat, nifty training, but the commercial sector, they didn't care. They're like, okay, I just sell hammers and knives. What do I care about data? Well, then they started having data breaches, and then they're like, oh wow. So now they're getting all of the people that buy from our store. They're getting all their information, and that information can be analyzed, and later you can create like intelligence reports and stuff like that. Like, okay, this is the profile of the person, credit cards, all this stuff, and later can be sold in the dark web. Now, while I'm presenting, feel free to ask questions. So if you have questions, feel free to ask. This is not meant to just be me lecturing. This is meant to be interactive. So if you have questions, feel free to ask. Tabisa will just pause me, and then you ask your question, and then I will, I'll talk back and stuff like that. All right, so here it talks about Industry 4.0. So we'll start off 1784. So Industry 1.0, this is mechanization, steam power, and the weaving loom, right? 1784. Now, Industry 2.0 is mass production. This is when you have the assembly line, right? So electrical energy. So this is the assembly line. It's 1870. So nearly 100 years later. Now, jump forward, you have Industry 3.0. This is 1969. So here you have automation, computers, and electronics. So 1969, and the Industry 4.0 is today. This is what's called Internet of Things, or IoT, networks, cyber physical systems. What you see here is shows ERP. ERP is enterprise resource planning, right? So I have a system that can track the first in, last out, whatever. Well, first in, last out, whatever. It's for supply chain. I'm not a supply chain guy, but there are different ways of doing inventory and stuff like that. And the ERP helps with that, finance. So the ERP system brings in all these various departments, and it brings into one system that you can actually see payroll. You can see what items are there. You can track items, and that's what ERP is. And then, of course, here you see an actual device. This is a mobile device of whatever it may be. And then, of course, you see the automation with the actual manufacturing floor. And that's what kind of show, like, really the hyper-connected system here and the complex network that is used in Industry 4.0. What is interesting is that when you look at raw numbers, like in my country, in the United States, today we have over 500,000 jobs in cybersecurity, over 500,000. In the metropolitan area that I live in, the Chicago metropolitan area, we have over 15,000 job openings, over 15,000 job openings. And the biggest issue is we don't have enough people to put in these jobs. And that becomes a big problem. So when you have industries that are pushing towards more internet-enabled devices, they want to have more complex networks, they want to use more modern technology or modernization, it's okay. But the problem is these systems get put out there, they're not secured, they're not updated, they're not patched, they're not locked down. And this creates huge issues for the organizations. Huge. Imagine your network at work, your HR network, within your network, you have your HR department. Imagine all of your information within that department being available, right? So whoever set up the network, they have there's issues in terms of the database that captures everything. Now that particular database is wide open. Now someone can see all that information. So within a human resource organization, within that department, you have your name, whatever your government ID is, information for your family, point of contact, whatever insurance plan, healthcare plan. If your healthcare plan's up there, maybe they can see even more detailed information about the healthcare plan. If you have to clock in and out, the hours that you actually work, so those hours are in there as well. Payroll, all these items are captured in the HR system. And also your credentials for logging into other systems. So now it has your employee ID, maybe your passcode. Maybe that employee ID and passcode is used among other systems within the network. So now they can take that employee ID and passcode and use that to get into other systems. And plus, if someone had access to HR, they can see what role that you have and then figure out, okay, well, let's see what Maurice has. What can he do? What access does he have? And let's see if I can use his account to maybe see if I can elevate privileges to another account, or maybe I could do account creation or deletion using his account or something like that. And then also in terms of attacks, someone could, they could hijack the actual files. They could encrypt it. So now you have encrypted files. So you have ransomware now on your HR system, and now you can be held hostage. There are so many different scenarios that can occur. Now, the scenario that one may not even think about is your competition. So one of the things that I realized when working in aerospace and defense is that a lot of people can do the same thing, right? our differentiating factor was that we could do it quicker and we could save costs. We call that lean manufacturing, right? So Six Sigma, lean manufacturing. And so a lot of those processes are kept proprietary. Like you don't share these processes because other people can just implement them. And so imagine someone getting into the system only to figure out what are your processes so they can replicate that. And so when it's time to bid on another proposal, they can simply say, hey, we can do the same thing this company can do. And they figured out a way to do it even better than you've done because they have your processes and they can figure out, okay, we can merge these two processes and we can save, a month in production, or we're willing to work around the clock. So now your bid is no longer competitive. So what I mentioned earlier was about Stuxnet. And so here it shows the first 5 victims of the Stuxnet worm. So here you'll see in 2009, it was a engineering company, an ICS vendor. And then you see that it was another organization, and it just says the source of the global Stuxnet epidemic. Now, I do have to say something that Stuxnet and Flang, these particular items knew exactly what configuration to look for in terms of an attack. So they knew that configuration. They're able to determine, hey, this is the configuration. So this is where we need to launch the attack. So this is how complex this actual worm was. So a lot of individuals may have had the worm, but then they knew exactly how to propagate itself over the network and stuff like that. And so you can just see here that this was not something that was sent for overnight success, right? The goal was long term. So that's why a lot of people believe that this particular attack was nation state. When you have attacks, there's different levels. You have what we call a script kiddie. Script kiddie is just some guy or gal that goes on the net and they find a previous written malicious code, they modify it, and boom, they kick it out. Then you have the hacker, right? The hacker is more knowledgeable, right? They're more knowledgeable what they're doing and stuff like that. They still have limitations because they don't have a budget. They have no real budget, right? It's not, they don't have endless funds. Then from the hacker, then you go to the criminal element, right? So now you're going to mafias and stuff like that. And so you're going to more of a criminal element. So of course, their budget is a lot more, and plus their motivations are different as well. From there, you go into what we call nation state. So nation state would be like North Korea's hack on Sony and stuff like that. Nation state is when you have the resources backed by a nation or nations to perform an attack. So you have to think about the motivations of the actual attacker. And so that all this is to show that you can see that this did not happen overnight. And from the reports, it was nation state. And you can see how this particular worm moved throughout these organizations till it actually got to the centrifuge developer and then finally landed in the actual organization, this targeted organization. So right here, this is this talks about, this shows IoT. So here you can see like the full perspective of everything. So you can see here the manufacturing plant. So monitor production. So you're monitoring production and real-time flow, eliminate waste. This is that whole Six Sigma lean process I was talking about. Manage equipment remotely. So imagine being at home and you have your tablet. You're like, okay, I want to see what's going on with the organization, how the manufacturing floor is. You can, log in remotely and say, all right, I'm going to see what's going on remotely. The problem is if it's insecure and you're logging in remotely, so can other people. So yeah, you're at home checking the manufacturing floor. Other people can do the same thing. Because all right, well, let me look at the organization. They can see exactly what's going on. The other item is, it says implement condition-based maintenance alerts to eliminate machine downtime and increase throughput. So machines will get hot. So you will probably have to have the machine down. So imagine a particular attack that shows that the machine is not hot. It's not overheating or anything like that. The machine overheats, now it's down for a week, if not weeks. When you think about data science and business intelligence, when you see here the individual scanning a particular item with the RFID, those items become they're data, right? It's data that allows you to do a lot more things within your organization and be more efficient and effective. When you look at the customer site, here you can see third-party logistics, right? So now you can see third-party logistics, how it gets from point A to point B. What's interesting, does anybody remember what the Solarwinds attack? So we're going to take a quick interjection. Does anybody here remember the Solarwinds attack that happened recently in the United States?
I do, Morris.
Okay, tell me what you remember, or what you what was the issue with the Solarwinds attack?
Sorry, I really don't have the full detail, but I think I remember it was in the early 2000s. So the details in my head are quite sketchy.
Okay, so the Solarwinds attack actually just happened recently. And so this was the attack that let they believe the Russians get access to a lot of federal systems. This attack is interesting. Yeah, this attack is interesting because what it does, it attacks third party, right? Third party development, third party logistics. When you're using software, we'll say like Adobe, it doesn't mean that Adobe developed the entire software. It's just the stamp of Adobe. What happens, because in our society, in our global society, many people work on a particular product. You know, maybe the developers come from Botswana. Maybe they come from Germany, maybe South Korea. What happens is that the standards for actually developing software in terms of security checks, quality control, they're all different, right? Because there's no requirement for a global standard. There's a common criteria certification, but that's only for certain products that may be bought by various governments. But for your everyday stuff, there's no requirement for that. So now you have this stamped software, this software that you can actually use and install, but you have no clue if one of the other suppliers, your suppliers, subcontractors, actually fell victim to malicious code. You have no clue. So you were like, okay, I have this final application. I'm going to give it to my my customer, and you have no clue exactly what happened in between. So there's no requirement for static or dynamic code analysis. That is simply looking at the code, seeing what common weaknesses, enumerations, or vulnerabilities and exposures are there by doing a line-by-line analysis. There's nothing that looks for faults or bugs or stuff like that. It all gets wrapped up and is sold with that large company's name, and it's just passed through. So that's a big issue. And that's another way of attacking. There's actually a certification through the International Information System Security Certification Consortium, IC squared, the Certified Secure Software Lifecycle Professional, or CSSLP, that goes through these items, and they actually cover supply chain management, because now there are attacks in supply chain. Again, you find the weakest part of an organization and you attack that, or a process. Because when when people are thinking about attacks, you're thinking about how much money, how much time that they're going to actually put to do an attack, right? Because if it's a nation state, they might have unlimited resources. But if it's a simple hacker or a criminal element, they don't have all that time. So they have to think about, okay, what is the best way to launch an attack or to get around whatever security controls are in place. So if you can actually go through the supply chain and input malicious code in that particular supply chain, from there, you can probably save a lot of money going into that weaker organization, getting access to their putting in your malicious code there, and then just having them wrap everything up into the larger organization. Now, when you look at global operations, here you have research, development, field services, and management. So here, these are other items that are part of the cyber physical system. So all of this wrapped together is part of industry IoT. So it's a lot more expansive than you think. So it covers a lot of different stuff. And this here just shows all the various areas that you have to think about in terms of technology. So when you look at global facility insight, customer site insight, and global operations, think about you have your intranet. So you have what's internal to the organization, and then you have the extranet, and this allows individuals, customers to like check on the orders, see what's going on. Imagine you buy something from AliExpress and you need to check and say, okay, well, where is my order? Is AliExpress or Alibaba, are they going to send my stuff? So you're checking and you're like, okay, well, now my package is in SA, right? My package is in SA. You're able to see it there. Imagine that you checking your package, someone else can track your package as well and intercept it. So that's why it's important to make sure that when you have these systems working within this manufacturing plant, these connected systems, that it is secure throughout the entire process. The entire organization needs to be secure. Now, this was something that I presented that was published in the London Times, well, the Times Sunday and the London Times, right? So this was based off cyber attacks, preparedness, and UK manufacturers. And so here it just says nearly half of all the UK manufacturers have experienced cyber attacks. Nearly half. So imagine nearly half of all the UK manufacturers experiencing cyber attacks. And when there was an actual survey done, it says we monitor and protect their systems and software from cyber attacks, 75%. Okay, that's decent, but it's not good. But if you look down and it says we have insurance to cover loss due to cyber attack, only a third said they did. So when you have a cyber attack, they may just disrupt operations of the system. It costs money, lots of money, to get your system back at the speed, and you lost data, you've lost money. And imagine every day you're expecting a certain amount of output. So you're expecting a certain amount of money to be made. What is really interesting when you think about Saudi Aramco, so Saudi Aramco is the oil company for the Kingdom of Saudi Arabia, and when their systems were attacked, they have lots of money. So, but what they had to do was they had to scrap their systems and fly in new systems on aircraft to use in their facilities. Regular organizations do not have that capability or capacity to do those things. So if they experience a cyber attack, they're offline. That company could die. That could be it of the company. When you go to the next level, it says cyber security is managed at board levels. Only half said it's managed at board levels. The problem is when you are trying to push initiatives to see exactly what is going on, or get people like the CEO, the chief executive officer, the chief financial officer to care about what is occurring, it is extremely important to have these high-level people to have insight on what's going on. It is extremely important. So if you don't have someone at that C-suite, is what they call it, to care about what's going on, then they are going to push cyber aside. When I was working in cyber, and this was for the federal government, I always had to advocate, hey, on this technology, we need cyber, right? We need cyber. On drones, hey, we need cyber. Why do we need cyber? Well, I think it's an issue because our data links aren't encrypted. What happened a few months later made national news because one of the drones, people were actually able to buy they bought a satellite, and they used like $35 software, and they're able to actually see the actual data from the drone, what the drone was looking at. Late after this happened on national news, later the government was like, hey, we need to make sure it's encrypted, right? So because what the board is trying to do, they're trying to manage cost. They're trying to say, all right, well, let's think about ways to save money. Let's look at ways to save money, and let's see what we can do. And so cyber has always been on the chopping block. Only in recent years, individuals have cared about cyber, right? It was called automated information system security. Then it was called information security, network defense, information assurance, and now cybersecurity. It's like the name changes, like whatever sounds better, it changes, but it's all the same thing. And then if you look at 62%, it says we train our staff in cybersecurity. This is frightening. So imagine you get an email, right? You get an email and you have no clue. You think it's legitimate. I want to talk about the famous 419 emails, right? We all know about the 419 emails, right? So the famous email, hey, I'm a prince. Provide me, give me your account, and I give you some money as a show of faith. So you get some money. You get some money from this account. You're like, wow, this prince of Delta State has given me money. Okay, let me give him some other credentials because I just got a lot of money from him. And the next thing you know, that all your money from your account is gone. So you have to be able to train your staff, not just in cybersecurity, but the actual attacks that your organization is going to get, because every organization gets attacked differently. And so when you see that only 62% of the organization is trained, this becomes one of your easiest points to go attack. So you know that the organization more likely doesn't have insurance. Their employees aren't trained. And when it says risk register, this means that the organization has a register of risks that come up. They say, hey, there's a risk that we have employees leaving. We have a risk that based upon our location, there is going to be, bad weather or something like that, something that's going to interrupt power. So these items, they all work together and it creates just tons of issues. So imagine you have staff that's not trained. They're thinking that they met a prince or whatever. And they say, hey, open this email and open this document and you'll see everything about my account and what you can do. They open this document, it's malicious code, it encrypts, it's ransomware, it encrypts everything on their system and connected systems. And now you have no insurance to protect against the cyber attack. And they say, hey, we need $1 million pula, or we are going to delete the information within 24 hours. So you don't even have insurance to cover the ransom. And then plus, you don't have really an option to actually, you don't have an option to like fight the attacker. You have to comply, give them the $1 million pula, and then hope that the unencrypted files are safe and that they haven't copied them and sold them elsewhere. So it creates just tons and tons of issues. And that's why manufacturers have to be prepared for cyber. Now, when you look at the Middle East, right? When you look at the Middle East,
there's a question.
Okay, yes, please read it.
Ohana, please go ahead.
Yeah, Morris, sorry, I just had a quick one on the previous slide. If you just go back one. So I think I think the first point there is that while those figures you might think are not necessarily to the right level of scale that one would actually want them to be, I will say that they're pretty high if you compare them to our regional average this side of the world. I actually find them quite impressive, just based on the knowledge of the regional state here in Africa, particularly in Southern Africa, I will say that. So then the other part of the presentation there talks to, the human element of actually cybersecurity, which is this idea of planting espionage moles or mules within your organization so that they can go in and actually, launch attacks into your organization. I just wanted to understand how that human element is taken care of in slightly more advanced environments, because it's quite difficult to harvest.
Yeah, so one of the other things when I talked about in terms of my research and looking at developing countries, so I spent a lot of time looking at cybersecurity in African countries, particularly the AU, right? So I looked at cybersecurity and also terrorism in Nigeria, Central African Republic, Islamic extremism, and then also with Somalia, so Kenya, Ethiopia, and stuff like that. So if you look at the AU, right? So the AU was built by Chinese, right? So that's like the European Union having all their government buildings and equipment supplied by a foreign nation, by the Russians. Imagine, all the politicians of all these European countries say, okay, Russia, you're going to build our most important buildings for talking classified stuff, talking about what we're doing in our nations. And so that's what happened. That's happening now. And so there was actually a report done that they found out that at the end of the day, that the servers were routing information back to China at the AU. So you're talking about 54 countries. You're talking about Somaliland. You're talking about Western Sahara. These nations sending information back to China about what they're doing within their countries, various initiatives they're trying to do and stuff like that. So it becomes a huge issue. So that's one thing, right? And I think one of the biggest things about this continent in a lot of countries is that where your technology comes from. Like we have an issue with Huawei, right? I mean, I'm not gonna lie, they have really good phones. They're really affordable, but I would just leave it at the phones. But imagine when you're talking about like 4G, 5G, and they're actually putting the backbone of these systems in your countries. So now they have the ability to see all the data that's going on. They're able to launch attacks and stuff like that. So that becomes an issue in terms of your infrastructure. There is, if you look online, there's cable leaks, and it talks about the various information that has happened in SA. So Pretoria is dubbed as the new El Dorado of espionage. There's a report that was done, and it talked about leaked classified documents, and there were over 60 foreign agents or spies in Pretoria. Over 60, from Senegal to Mossad and a ton of other nations, and they were there operating in Pretoria. Pretoria is not that far of a drive, and it's an easy flight from Gabs, and it's your neighboring country. Yeah. So it's interesting to see like what is occurring just next door, and that is what is scary. So this is new reports published, well, not published, but someone basically leaked the report, or someone is an attack, and you'll see all the reports from the South African Intelligence Agency, all the stuff that occurred. Like they had government computer systems that were inadequately secured, that people were able to like breach, which is scary because in this region, SA pretty much controls this Southern Africa. They don't say control, they're supposed to be the leader. And if you have the leader within your region getting attacked so easily, then you think about, okay, well, what items are we leveraging from SA in terms of technology, banking, and stuff like that? Because if they're having issues here and they're able to get penetrated here, if we're using these same technologies, same network, same infrastructure, our systems are vulnerable as well. And I think that is the big thing.
And more,
that
just
is a big thing.
And just to add on to that, in this country, again, we have a really huge problem. Like you're saying, we depend a lot in South Africa. All our banks do, if not all of their transactions and their servers are hosted in South Africa. And you are like talking about Huawei, all our networks, we have 3 mobile networks in Botswana, and all of them, the backbone is Huawei, and we are not even 5G. So the amount, and to even make it even more interesting is the fact that we have very weak cybersecurity infrastructure, and we have very weak data privacy. Literally all the data and all the information in this country easily live without anything that is stopping from leaving the country. I mean, if China could listen to the African Union, for us, even this conversation, I could bet they could probably be listening to it. There's another hand up. I don't know whether you want to finish with Ohona or take Tato's comment now.
Oh, let's take his comment now.
Okay, Tato, please go ahead.
Okay, thank you very much, team. I think it's a very good presentation. I think we need to join hands, both the private sector as well as the research institute, because as you're well aware, you're speaking very good regarding issues around privacy. We had the Data Protection Act, which have been enacted 2 years back, which has significantly not been able to be enrolled. And one of the aspects that also on the Data Protection Act, it speaks about data residing in country, as well as in terms of how we need to provide the controls on it. despite that, we've got all of those policies that we have, but the implementation is a very big problem. I think we need to join hands, both private and the research institutes, to be able to start evangelizing to ensure those are implemented so that our cybersecurity hygiene can be improved. Thank you very much.
Thanks a lot. Mo, before you address those two, I forgot to do this when we did housekeeping. It would be nice, especially for those who are external, when they speak, they introduce themselves so that we can appreciate how many people are out there. So, Tato, if you could just introduce yourself so that we are, and especially where you are from, so that we appreciate.
Thank you very much. I'm Tato Jordan. I am currently head of IT with Botswana Agricultural Marketing Board, but prominently I'm into digital transformation and cybersecurity consultancy. I happen to be one of the few cybersecurity experts in Botswana. 12 of us, we are currently CSIS, and I happen to be one of the Africa only and this cybersecurity professional trainer. That is who I am. Thank you very much.
Thanks a lot, Tato. Mo, go ahead.
Okay, sure. All right, so getting closer to this continent, it's talking about Middle East attacks. And so this is SAPM, and they reported massive attacks on their servers, with the majority of their attacks occurring in Middle East, in Saudi Arabia and Middle East. So, and it says approximately 94% of the companies in the Middle East and Africa stated that they had been a victim of cyber attack in the past year. And this was in 2018, so it was 2017. 94% of the companies in the Middle East and Africa stated they've been a victim of cyber attack. That is almost 100%. Generally, when you look at risk management, when you have risks that are at 85% probability of occurring, it's a known fact that it's not only a risk, it's a reality. So the reality is that every company is being attacked here. And so that's something to think about. Every company is being attacked. All right, so going into more of so now you have the background of why this is important in terms of cyber and stuff like that. Now we talk about the lab environment. So at our institution, we have the remotely accessible dynamic infrastructure for students to hack, Radish. And this is just the environment that students have. And so basically it's a virtualized environment that allows students and maybe you're training industry, and you can do everything remotely, right? So it's virtual machines, it's VMware, you have VMware Hypervisor, Hyper-V, you have a Windows VM, you have Kali, and you're able to attack systems and stuff like that and set up environments to do that. The problem is you need something that is going to be affordable. Like that Radish environment is not affordable. We not for organizations like here. So say if it was $200,000 in the States, it's 2 million Pula here. That's a lot of Pula to create an environment that you may want to replicate at multiple institutions. So you have BIUST, you have University of Botswana, and you have the other institutions, because what you want to do is you want to educate as many people as possible in cyber. So you're creating computer scientists and information system graduates that understand what they need to do. So this is a framework that I created in my second doctorate in the UK. And so it's called the Mission Framework. So it looks at education, policy, and technology, and these interwoven framework. And so say that you look at the policy says that you have the internet law or Act of X. So that particular law, it will affect technology and it will affect education. So now what technology is affected by policy, and then by education, what type of educational standards, whether it's university, professional education, or just general training, needs to occur, that individuals understand how this policy affects them, and then how they need to utilize the technology, and then how the technology needs to reflect the policy, the implementation that needs to occur from the policy. So this is to tie in three themes for any organization or any nation to truly represent their country. And so this talks about using this in a virtual lab environment. here just showing an example of the lab, and this is something that we are going to be creating at our institution over the year. So this represents, so you have just a regular device, you have a remote interface to a virtual machine. So you have access to the system on any device, remote access. It could be any remote desktop client. And then you're given a machine. This is a Kali virtual Linux machine. Then you have a router, DNS server. And then from here, you have different environments. You have what they call live operating systems. So you have maybe it's Tails, Linux, Windows. Then you have mobile device images that you can have access to as well. Then you have exploitable web apps and servers. And then you have IoT devices. There's a lab from Georgia Tech that shows a IoT system. This is the open source one that you can use. The full environment is quite pricey. So again, we designed this with the thought that we would actually use this in developing countries or countries that didn't have large budgets to create these labs so that they could provide this training. But as you see, the dedicated virtual machine, offensive security, the Kali machine, would have access to actually run attacks and scans on all these different systems and use this as a way to harden their current network, or they could duplicate their network in this virtual environment and see how an actual attack will be launched, or if their system was hardened enough before they actually deploy it in a actual real environment. So think of like simulation. You're running through a sim, and you have a sim that represents near what you have actually on the in the manufacturing floor. You're running your various scans. You're seeing what vulnerabilities exist, and then you're like, okay, well, it looks good to go. I just need to patch these items out, and then from there, you create a software release or a release to an image to harden your systems, and then you have your system go out there on the floor. That's what this is to do. So this lab is to solve multiple things. This is Oracle Virtualbox. So the VM would have maybe like, if it's a Kali VM, then they would have a Kali machine. This just shows how it would look. This is Oracle Virtualbox. This is open source. So this just shows how Oracle Virtualbox looks. You can see damn vulnerable web apps. So this would be one of the vulnerable databases. And this could be like for practice and stuff like that. So you have students that need to practice. If you look to the right, that on the right is simply just pinging the actual web app. You see if it's live. This is basically a bridge network on Oracle Virtualbox. This is running on Ubuntu Linux. And so just ping it to make sure that it works. And then, of course, that you can see it works here because you can't see it, but it's the IP address for this other this vulnerable application. So running tests and stuff like that for practice. Because one of the things in terms of cyber, so a lot of institutions will teach cyber, which is interesting, but the theory and application are very different. I can talk about, hey, this is how you develop a system. I'm teaching operating system class. Hey, this is how you should lay an operating system. It sounds great in theory, but until you've done it, you really don't know anything. You just know theory. You just know what's in the book. You read a book, you understand what's in the book, you can recite what's in the book, but you can't actually do the things that need to be done. I say, all right, well, you understand operating systems. I need to go in here and replace the file management system. Or, hey, this is messed up. If you're using Linux, hey, Grub is messed up. I need you to fix this. You're like, oh, well, in the book it says if Grub is fixed up, it means there's a problem. Okay, yes, that's what the book says, but I need you to go fix it. And so that becomes the issue a lot, especially in academia and industry, right? Industry says that you should be able to do these things hands-on, but the problem with that is you may not know the reason why you're doing it hands-on. You just know how to fix it. So you're fixing this stuff, but you have no clue why you're fixing it. Theory says, hey, this is why this needs to be done. This is the problems that could arise. This is how you should lock it down. Theory sounds good, but at the same time, it says, okay, you just told me what needs to occur, why it needs to occur, but now I need you to do it. And so the goal with this lab is to fix that disconnect, and so that students, employees can go in there and say, I know how to take the best of both worlds and turn it to application. And so that's what this whole lab environment is to do. This right here just shows another example. This is Kali. So what you see here is Kali Linux, and this is this SQL map. This one, right? SQL map. And so this is just showing, when I talked earlier about the database, HR database, how it's facing and how it could be vulnerable. I'm just running an easy SQL map, and I'm running it against a website that's okay for running it. This is actually okay, a legitimate website. Not a legitimate website, it's an organization, but it's a website that was actually provided for running these attacks. And I'm just running an SQL map attack. And what's interesting is some of these attacks on Kali, they're automated. So if you can use the command line, it's fair, you're just type in SQL map space -- wizard. It brings up a wizard. You copy and paste the URL link, and then from there you choose easy, medium, hard. I hit 3. I hit another 3, and then it just runs. And if there's an issue, it will populate all the items up there, and it'll say, hey, there's an IDS, there's this, or there's that. And if not, it just populates all the usernames and passcodes. You'll get a hash for the passcode. You can just go online and you can just do convert hash to just convert hash, and you can take the hash in there and it'll convert it to the actual letters and numbers. Now, in terms of scanning, this is just an example of a scan. Yeah, so I just scanned this on some website. And so when I scanned on the website, it pulled up all the open ports, right? So when you're talking about a manufacturing floor, and when I talk about hyper-connected systems, port management is important. So now if you look here, you see all these various ports that are open, right? You see this TCP port, you see this item port. So all these ports are open, and this is ran on an intensive scan. This is Nmap. You can run Nmap, but Nmap is just it's just the GUI. It's a graphical user interface for Nmap. And you see what I actually ran it against. I'm not going to say exactly what it is, but if you can read, I think your English is better than mine, but you can see exactly what I ran this against. And you can see, the scary part is you see the organization, and you see exactly all the open ports on this organization. It's frightening when you think about it. So imagine manufacturing organizations that need to lock down their systems, and then how many organizations are doing even more things than that, and they do not have the proper security controls in place to make sure that their organization is not going to fall victim to an attack. Now here, I just talked about issues and future directions. So, they're just saying that there are indeed projects that have saved money by adopting desktop virtualization, and most don't see any ROI, return on investment, at least for a few years. So basically, to justify the actual type of technology and stuff that's going to be used is a little bit different, right? So you have to think about the initial costs, so licensing costs, initial infrastructure costs. It's going to exceed maybe the initial benefits, right? It's going to exceed it. However, what you can do, you can start minimizing some of that stuff, of course, with licensing and stuff like that. And so, like I said, the goal is to make this affordable. And so here, there are just a few issues, like there's issues in finding an open source virtual desktop infrastructure, a fully open. A lot of times there are things that you actually have to pay for, licensing and stuff like that. Issues in hosting the mobile device images. So there's issues doing that. So when I talk about the mobile device images, there are issues hosting that. And then also ensuring that they have the ability to operate as if hosted on a native platform. So for those that develop apps, you have these emulators that you can actually try the app on and see how it will look and stuff like that. But to have something that's going to work as great as the native environment, that is an issue. And then the whole goal is to have the goal is to have a fully open source environment, so that developing countries are not burdened with the associated cost of software licenses. That is one of the big things. Is you can take repurposed hardware and you can run what they call lightweight images. And these lightweight images can run on these bare bones systems, but you still got to pay for the licensing costs of some of these hypervisors and stuff like that. So that concludes my presentation. I think I may have, so I have my old business card. So this is my email. So mdawson2 at iit.edu. The address for me doesn't work where it says ITM and C2 safe, but if you type in my name in the institution, it will come up. So we just switched from the School of Applied Technology to College of Computing. We did a merger. But yeah, this is my contact information. But while I'm here, I'll be at BIUST. While I'm here for a number of months. So if you have questions, feel free to meet up with me. Of course, COVID is a big thing now, so we have to be, safe about that. But I'm always open to talk via like a scheduled Google Meet or something like that to talk about more of your concerns or issues or maybe things that you want to do in terms of research. For students, I really hope that you consider going towards cyber. Cyber is big. There's lots of jobs globally. There are going to be a few million jobs open globally within, I think, like the next 24 months. And already in the States, there's over 500,000. So in terms of cyber, there's opportunities to do lots of various stuff. The opportunities there are there. So I'll conclude, and you can ask any questions that you wish. And what I'm going to do is I'm going to stop presenting.
Yeah, we have Tato and Dr. Mpweling. So we'll start with Tato, then followed by Dr. Mpweling.
Okay.
Thank you again, Maurice. I think it was very eye-opening in terms of the good work that you're doing. I believe it's one of the effective eye-opener to us as a country. But maybe just to add on what you just said, I think it's more important for us to really look in terms of developing open source virtual desktop infrastructure. And then the other aspect, it's more important for us to, while we are moving into the trying to develop more experts on the cybersecurity, we need to deal with the misconception around cybersecurity as an IT issue, which is much more prominently a business or an enterprise situations. Like we always says is currently organizations are doing digital transformation. And the most paining thing is they're not focusing on the other side of the coin, which is cybersecurity. They're much more interested in value creation instead of value protection. And it's more important that we need to ensure that we close all those gaps so that we build up cybersecurity with digital transformation instead of bolting in. Because prominently, when you start bolting in, we are going to end up having exorbitant cost trying to close up those vulnerabilities. Thank you very much.
Thanks, Tato. Dr. Mpwelengo and so more can comment on the two questions at the same time or comments.
Okay. Thank you, Mo. My question is, it could be for just discussion, or maybe if somebody knows, not just to you, but I think you probably know. What has always puzzled me, you talked about the nation-organized attacks like NK, Iran, Russia. It is a company called Kaspersky. How has it successfully gained popularity across the world, even though there are rumors that it's linked with FSB? FSB is the CIA of Russia. It always puzzled me why this company from Moscow is dominating in supposedly antivirus tools across the world. That's
Well,
it.
yeah, so it's interesting when you look at companies like, we'll start with Huawei. So Huawei, they're basically the leading tech company in China. The issue is in certain countries, governments may have the ability to get reach back, right? They can reach into the organization and say, hey, we've been supporting you. We want this data to be given to us. Or we want to, if you have fiber, we want to listen in and see what data is coming. We want the ability to see the same data you're seeing. Now with Russia, they actually have a tech city, and their tech city is supported by their Silicon Valley is supported by the government. So that becomes an issue when you're operating in a country where the national government of that country has a significant hand in what's being developed and stuff like that. And so now you have this organization that's developing antivirus and for a fairly decent price. And now you're like, well, we need to think about these concerns for national security. So, it may be not a big issue in terms of personal use, but when you think about national security and, are you using these on federal government computers? Are you using these on critical infrastructure? It becomes an issue. And that's why many more countries need to take, I guess, a prominent role or primary role in developing systems that are used by their country. Right. So if you're going to have computing devices, are you going to get your technology from this country? And if you are, you need to be able to lock down that system, see the source code, lock down the system, check for any backdoors, whether it's software or hardware, and then actually use that particular device. The problem is that, in the States, we've gotten fairly cheap in terms of cheap labor and stuff like that. So we get these items like, okay, well, let's buy this product. It's cheaper. Right? It's more cost effective. But at the end, it's an issue because now you have no clue what actually went into the development of the system. So that becomes an issue. Again, we build like chips and stuff like that. But when you look at just other devices, we just don't do it. It's just not our country. It's not our expertise to do that stuff. It's very specialized stuff because it's cheaper to have it from somewhere in Asia and then have it come over to the States. Now, when you think about here is when you're getting these devices and you don't have expertise to review the maybe the logs or stuff like that, it's a big issue. I'll give an example. I did work back in Senegal in 2016 and 2017, and so a lot of the actual devices they had copies of Microsoft Windows that was it wasn't genuine copies of Windows. To say it like that, they had the red flag, the red banner that said this is not genuine copy. This particular version of Windows will not get any updates. But it was the actual Ministry of Agriculture that used these systems, right? It was on their network. And so that there was a huge red flag in terms of making sure that this particular system can be backdoored because they were not receiving any updates. And there's updates for systems that come out daily. So now you may have what they call zero-day vulnerabilities that are going unpatched because you're using a legitimate copy of a particular system.
Yeah. Are there any comments? Please raise your hand if you have any comments. Just to let you know that I just put up a link on the chat. This is a talk that Mo gave before he came here, understanding cybersecurity risk during the rise of working from home. So I just thought I'd share that with you. So you can open that or you can copy the link and then you can watch the video after this. So don't worry, that is not an attack from me. I don't want to steal anything from you. So are there any comments, Dr. Tabona? I think you had your hand high at one point, raised at one point. Dr. Tabona. Okay, I think he's having problems with his system.
Can you hear me now?
So sorry, I was having issues. Were you talking to me? I was having connectivity issues. Yeah.
No, I was saying Dr. Tabona.
Can you hear me now?
Yeah, we can hear you now.
Yeah.
Please.
I was just saying I wanted to appreciate a point highlighted by Mo with regard to virtual labs. The fact that we can save cost when we turn to virtual labs instead of trying to procure the whole hardware, which is obviously going to be more expensive. And we are like in BIUST, we are about to set up a cybersecurity lab, which the Vice Chancellor has supported us and the Office of Research. So I think Mo will be here for about a number of months. I think we'll use his expertise in that regard to kind of build a cybersecurity lab. And then the money that we've been given, I think it's around 3 million pula. I will try to see how we kind of use it for licenses and then buy minimum hardware. I think that was a good point. I think many people are not going towards setting up labs because they want the physical one. But like he highlighted, a virtual lab will definitely benefit as much as the hardware lab. Thank you.
Thanks a lot, Dr. Tabona. We still have some time for comments and questions. Comments, questions. While people are still thinking about comments and questions, allow me to, especially for our external participants and even those around, allow me to share something that the cybersecurity group in BIUST will be hosting very soon. Can you all see my screen? I don't know what you can see. Can you see my screen?
Yes, we can.
Okay. So the Cybersecurity Research Group is planning a virtual cybersecurity symposium. The theme of the symposium will be our cyber state of affairs, securing Botswana's cyberspace for all. The event will be held on the 2nd to the 4th of March. This will go out in the media soon, but I just wanted to show you those who have not heard so that they have an appreciation of what we'll be having. We'll be having several talks, overview of the cybersecurity globally and Botswana perspective. This will be given by either the Minister of Defense or the Minister of Communication and Transport. Mo is going to give a presentation as well during the event. Mr. Mohalemam from Spectrum Analytics will give a presentation as well during the event. And Ms. Senolo Modise will talk about the Data Protection Act. We'll talk about privacy we'll cover privacy from 3 perspectives. We'll cover it from the legal perspective, we'll cover it from the technical point of view, and we'll cover it from the human side of things. When the last speaker there will be talking about online abuse and harm. We're also going to cover professional cybersecurity courses, which will come in handy, organizational capacity required to build cyberspace. We'll talk about who is that talk, which will be given by one of the partners who is available on the talk now, Mr. Uhona, Cybersecurity Operation Centers. So there will be a lot of activities. There will be panel discussions. There will be radio exercises, radio activities, and there will be live demos. I think there will be a live demo of a SOC, or there will be a live demo of a data management system, and there will be secondary school debates. So for those of you who want to take part or want to get more details on the event, please, those are the contact information. So you can pick any of the contact information and contact us, and we are more than happy to discuss that. Especially Mr. Tato Jordan, I don't think I have your contact, so I don't know whether Dr. Tabona has your contact, but it would be nice if you could drop one of us an email so that we can engage further after this. So the sponsors so far are Spectrum Analytics, ThriveAC, IQS, and Stencil. All the sponsors there, Spectrum, ThriveAC, and Stencils, are local companies. This is how we want to keep this local so that we can start having conversations at a local level and start coming up with solutions that will solve our problems, not relying on importing solutions like is the case. And we follow what Mo has just encouraged, that we try to develop solutions which are locally based and they address our problems. So I don't know if I've missed anything, Dr. Tabona. I just wanted to give a quick run of the event. If I've missed anything, please feel free to add.
Yeah, I guess my mic is good.
Yeah, it's good.
Okay. Yeah. I just wanted to say you spoke about Tato. We do have a meeting with him tomorrow. I think it's tomorrow. Yeah.
Okay.
Yeah. So he's interested in doing further education in cybersecurity. So definitely we'll have a chat with him tomorrow. And then if he's interested in anything concerning this, even the budget, maybe he has a big budget, he can sponsor some of the activities. We are open to sponsorship. Also, like I think Tato mentioned that we shouldn't look at cybersecurity as something that is in computer science only. Would like to appreciate people from different areas who joined the presentation. I think Jensen Anderson from Forensic Science is here as well. We usually have lectures with him with the forensic science. I do teach digital forensics, and sometimes I give them talks concerning digital forensics, and they do give talks concerning forensic science. So, which is a good thing to have people from different backgrounds to also join hands in terms of fighting cybersecurity issues. Thanks.
Thanks a lot, Dr. Tabona. Prof. Jansen, do you have any comment? Dr.
Yes.
Tabona just put you on the spot. Please go ahead.
Thank you very much, Chair. Much appreciated, and thank you for highlighting these issues for us and presenting to us this nice list of forthcoming talks. Very interesting to follow indeed. I just note that you are not concerned with the forensic aspects of this. I mean, how to push back when you experience something like that. How can we report to authorities? How can we make sure we are following the right pathway to battle the, well, I guess, illegal attempts to interfere with our business? Things like that is interesting to us from a forensic perspective. And we need to be experts in this area as well. And we are very happy to have Tabona on board. Thank you.
Thanks a lot, Prof. Mo, do you have any last comments, Dano, or anyone has any comments or questions? We still have like 30 minutes, so we are more than happy. Go ahead, Pendukani, please. Pendu, please go ahead. Oh, it's Dr. Tabona. Dr. Tabona, go ahead. Go ahead. This raise hand is next to Pendu, and I thought it was Pendu.
Oh, yeah. All right. Yeah. I think Jensen mentioned something concerning maybe what we would like to know, what is actually happening in states, like if you experience cyber attack or something. What was usually the procedure? I mean, there's a talk of cyber police and stuff, but I don't know if it's there in states. What usually happens if you experience a cyber attack? Maybe you can use those lessons to kind of come up with something locally.
Well, yeah. So there's interesting stuff. So like recently, they just reported that that if you actually paid ransomware, that you could actually be in trouble because you could be supporting a terrorist organization. That has just happened within the last year. Previously, the FBI would only look at ransomware attacks that were over $100,000. They had a certain threshold. So what people that did ransomware, they would say, "Hey, we want $90,000," and then they would say, "You know what? We want to be nice, so we want to offer you maybe 50,000." And so you're at a limit that the FBI doesn't look. Other organizations may not have the ability or capability to look into it, and so you end up paying the ransomware. So you have that, but again, there is a huge shortage in terms of workers, and in various sectors, right? So you have a lot of people that are working in the federal space, but the attacks are not just federal space. They're against Home Depot. They're against hotel chains and stuff like that. So there's just significant issues right now going on. And a lot of it is workforce and how do we actually deploy the people we need. Everybody's like, hey, we have these new technologies. That sounds great, but who's actually training these individuals? So there are huge gaps right now, and that's the unfortunate part. So we have laws in place, but the problem is execution. That's a big problem.
The same as here. Is there anyone in the office who can pop into Moore's office and help him with his power? He's running short of power, so that if people want to continue the conversation, we can continue it. Dr. Tawana, if you don't mind.
Yes, so Tabono came in here. He came in here pretty quick. He's a nice guy.
Or he wants to give you corona.
I hope not. I'm from the States. I'm expecting to give you guys corona, but hey.
Dr. Mpawo, I don't know if you have any comments or something that you'd want to share with the audience.
Right now, I don't have any comments because I just joined the meeting, so I came a little bit late for this, so I was held up somewhere.
Okay. By the way, Mo, you'll remember Dr. Mpawo. You just recently awarded him a PhD in cybersecurity. He's one of the few cybersecurity experts that we have in the university.
Yes, I do remember, and I do remember part of the condition for the award was I was going to be taken out to a nice dinner here, so I will wait for that. Oh,
Mpawo, you owe Mo some dinner.
Okay, I'll try to organize.
I don't know if there are any questions, but before we finish off, I would really like to thank all our external partners, Stencil Technologies, which is a local company which specializes in cybersecurity. They specialize again in SOCs as a service, SOCs as a service. So Stencil Technology, thanks a lot for taking your time from your busy schedule to come and join us. I don't know if you have anything to say, Mr. Ohona or Bami.
Thank you very much, Doctor. We appreciate the invite. It was an insightful presentation by Morris, and we thank him as well. We're obviously looking forward to being a key player in the growth of the cybersecurity culture in this country and regionally. We are seeing a lot of education in that area. As I was saying to Maurice earlier, we are quite far behind as a country or as a region in terms of just adopting the relevant protocol to protect ourselves. And as a company, we have taken it upon ourselves to set this infrastructure and put it in place. Together with some of the conversations that we are having with the institution, we hope that we'll be able to achieve this in the short term.
Ohona, please go ahead, share your details or your website on the chat, so that your contact details, so that if anyone is interested in contacting you outside this meeting, they have all the details. So certainly, please go ahead, feel free to share those on the chat. Even Mr. Tato, if you have something that you want to share with people on this agenda, please go ahead, feel free and share your details, so that whoever wants to contact you are free to contact you. We had a partner earlier who had to leave, Spectrum Analytic. They had to leave because of another engagement, but we do thank them in absentia for the time that they dedicated to this and for working with us. Dr. Tabon, I don't know whether you want to do thank you remarks, or I should give it to Dr. Mpueleng again.
Tabona, I'm giving it to Tabona.
Oh, okay, Dr. Tabana, please go ahead.
Oh, actually, I wanted to say a few words and then pass it back to Dr. Mpuele.
Unfortunately, you have it.
Yeah, no, thank you very much, Mo, and thank you very much, everyone, for attending the event. This event, I'm happy that we had people from different areas. We had people from industry, not just BIUST people. We are also joined by Dr. Ramukapani Marvin is in Bristol University. I think he saw the invitation very late, but like Thabiso said, this meeting is being recorded. We'll share the link for people to go back and have a look at what was presented. But all in all, I'm happy. We have started the conversation between ourselves in BIUST. You know where to reach us. This presentation was coming from the Department of Computer Science and Information Systems. We do have a research group, cybersecurity research group, which we mainly do the cyber research, training, consultation, and doing all the looking for vulnerabilities and stuff. And also we have a mandate to set up a cybersecurity lab. We are trying to also we are also looking into ways in setting up a cybersecurity operation center. Thabiso spoke about it, but there are so many opportunities. And when it comes to cybersecurity operation center, there is a lot in cybersecurity. Cybersecurity affects everyone. The government right now is promoting, is trying to push us towards digital transformation, knowledge-based economy, and we know what is coming when we move towards those technologies. So I'm happy with the talk. We'll share the links, as Thabiso said, so that you can have a look at what was discussed. But those are my few words, and we thank you very much more for the insightful presentation. I will be working with you for the next few months, 8 months or so, and I hope we'll make changes. We'll highlight to the industries what vulnerabilities they are facing and ways to mitigate against them. Thank you very much, everyone. Back to you, Thabiso and Mpuele.
Thanks a lot, Dr. Tabona. I think that draws conclusion to our seminar. Unless, of course, we still have 2 minutes, I can take one quick comment. Mo or Dr. Mpueleng, if you have one quick comment, then we are done. Okay, no one has a comment. So thanks a lot for your time. Dr. Tabona, like Dr. Tabona has said, the presentation was recorded. So if you need if you want the recording, please drop me an email and I'll definitely share the link to the recording. Thanks a lot.
Thanks. Thank you. Cheers.
Thank you.
Thank you.
Cheers.
Thank you.